Why learn C? In general understanding, C is a middle-level language. The middle-level language is somewhere between the low-level machine, understandable assembly language, and high-level user-friendly language. C reduced the gap between low-level and high-level language. Low-level control. C provides direct access to memory and hardware, making it ideal for system programming, device drivers, and embedded systems. Efficiency. C code, when optimized, can be highly efficient, making it suitable for performance-critical applications. Learning C is base for other languages. Understanding C's concepts strengthens your foundation for learning other languages like C++, Java, and Python. Portability. C is a portable programming language including wide compiler availability. C compilers are available for almost all platforms, making it highly portable. Standard library. The C standard library provides a portable set of functions for common tasks. System programming. Operating systems. C is used to write the core components of operating systems like Linux and Windows. Device drivers. C is essential for developing device drivers interacting directly with hardware. Embedded systems. C is widely used in embedded systems due to its efficiency and ability to control hardware. Game development. Game engines. Many game engines, including Unity and Unreal Engine, have C++ components, and understanding C can be beneficial. Performance-critical components. C can be used to write high-performance game components like physics engines and rendering pipelines. Relation between C and embedded system. C is closely linked to embedded systems, making it the top choice for many embedded system developers. Why C for embedded systems? Due to low-level control, efficiency and performance, portability, flexibility and expressiveness, common embedded systems applications, using C, microcontroller-based systems, IoT devices. C is widely used to program microcontrollers that form the core of IoT devices. Examples include smart home devices, thermostats, lighting systems, wearable tech, fitness trackers, smartwatches, and environmental sensors. Automotive systems. C is crucial in developing automotive embedded systems, including engine control units, ECUs, transmission control units, TCUs, and body control modules, BCMs. These systems handle fuel injection, ignition timing, and power window control. Industrial automation. C is used to program programmable logic controllers, PLCs, and other industrial automation devices. These systems control manufacturing processes, robotics, and machine tools. Medical devices. C is used to develop embedded systems for medical devices such as pacemakers, insulin pumps, and medical imaging equipment. These systems require strict adherence to safety and reliability standards. Real-time-based systems. Robotics. C is used to program the control systems of robots, including industrial robots and autonomous vehicles. These systems must react quickly to sensor input and make real-time decisions. Telecommunications. C is used to develop real-time embedded systems for telecommunications infrastructure, such as base stations and routers. These systems must handle high-speed data transmission and switching. Aerospace and defense. C is used to develop embedded systems for aircraft, missiles, and satellites. These systems must be highly reliable and perform critical functions. Relation between C and operating system, OS. C language plays an important role in OS construction. Its low-level control, performance, portability, reliability, and legacy make it an ideal choice for OS creation. C's critical role in OS development. Kernel development. The core of the OS is the kernel, which acts as an interface between hardware and software. The kernel is often written in the C language, as it provides the low-level controls needed to interact directly with the hardware. Device driver development. C is used to create device drivers that enable the OS to communicate with hardware devices like disks, network cards, and printers. System utilities. Many system utilities, such as ls, cp, and rm commands of Linux, are written in C for their performance and reliability. Shell development. Shells, which provide a command line interface to the OS, are often implemented in C to offer efficient command execution and scripting capabilities. Libraries. There are many libraries included with the OS which are used for various tasks. These libraries are also often written in C language.